So good morning to one and all present here. So my name is Krishna Kumar. So I am going to handle for you embedded system technologies. So before going to this embedded system, what is called as embedded system? An embedded system is a system which has a computer hardware and dedicated software applied for specific applications. So first we are going to see what is called embedded system and what are the major applications of embedded system. So under this introduction to embedded system, so what is meant by embedded system? Okay, so generally what is called as embedded system? So these are the topics we are just going to discuss today. So what is called as a system and what is called as embedded system and what are the components of an embedded system and what are the major classifications of an embedded system and what are the processors available under embedded systems and what are the other hardware and software applications used in embedded systems. So first we have to be noticed that what is called as system. So a system is a way of working, organizing or doing one or more many tasks according to a fixed plan, program or set of rules. A system is also an arrangement in which all its units assemble and work together according to the plan or a program. So that is called as a general system. Suppose, for an example, we consider a common analog watch as a system. So the example is under this analog watch. So what are the parts? What are the hardware parts? And what are the software used under this system? So there are some set of rules and regulations. So the rules is nothing but all needles move clockwise only. A thin needle rotates every second. A long needle rotates every moment. So these are some set of rules that abide this system. So that is one of the example for a common system. So next, another example for a system is a washing machine. So under a washing machine, it is an automatic system that has some set of rules. The rules here has washing, rinse, drying, and next wash over by clothes, and at last each step display the process stage, and in case interruption will execute the remaining. So some set of rules has been applied to that system. It is called as a general system. Another example for a system. So now coming to an embedded systems. Already I told you, embedded is nothing but the collection, the combination of one or two elements. Like suppose we just consider an hardware or the software part. So here under the embedded system, so an embedded system is one that has a computer hardware with software embedded in it as one of its important components. So already we have seen the system as a two example. One will be watch and another one will be the washing machine. So that has some predefined set of values. So likewise here under an embedded system, so we consider a common IC. So under that IC, the program has been embedded into the IC. The program that has been embedded into the IC. Suppose it is called as an embedded system. So the program that is embedded into the actual IC. So this is For an example, this will be the one of the embedded system. So commonly we just consider what are the common computer hardware parts. So one will be the microprocessor. Next will be the RAM, ROM, and cache memories, and input and output units, networking units. So under RAM or keyboard, mouse, monitor, printer, scanner, Ethernet card. So these are the different type of component hardwares that has been present under the embedded system. So now we are just going to see what are the major components of an embedded system. So embedded system consists of the three major components. One will be hardware component, and next will be the software component, and third will be the real-time operating system. So under the hardware component, one will be processor, timer, interrupt controller, IO devices, memory, port, etc. So these comes under hardware component. So next under software component. So what are the softwares we use to run the particular hardware? So that considered as a software, so which may perform concurrently a series of tasks or multiple tasks. Then third will be the real-time operating system. So under the real-time operating system, here all the systems that operated under the real-time functions. So based on some time slicing, based on some time deadline. So this RTAS defines the way of system work, which supervises the application software. It sets the rules during the execution of the application program. A small scale embedded system may not need this real-time operating system. So under the component of an embedded system, there are three types. One is hardware, software, and real-time operating system. So now we are just going to see what are the basic building block of an embedded system. So what are the main components that consist under embedded system, that present under embedded systems? So first one will be the power supply, reset, and oscillator circuit. So that is one of the module present. Next will be the input devices and output devices. So already you may know that what are called input devices, what are the output devices, and the processor, timer. So here you just see timer, and interrupt control, and memories. So that may be a program memory or data memory, which has an random access memories or recurring memories, and serial communication ports and parallel ports, system application specific circuit. So this we are just going to see very briefly. Suppose we just consider the power supply, reset, and oscillator circuit. Third one will be the processor module. Then fourth will be the timer module. Fifth will be the interrupt controller. Then sixth will be the memory devices, whether it may be a volatile memory or non-volatile memory. And next will be the serial communication port. Then another will be the parallel ports. And last will be the output. And here application specific system circuit. So we are just going to see this particular in depth. Okay. Suppose we just consider the module 1, processor, power supply, reset, and the oscillator circuit. So commonly microcontrollers need plus or minus 10 to 12 volt power supply. Okay. So the reset switch is nothing otherwise called as watchdog timer circuit. Okay. So this watchdog timer circuit which monitors regular period intervals of time. So mainly this particular reset switch is available in all type of embedded systems. Okay. So why we are using this reset switch is nothing but suppose if any problem occurred. Okay. So at the time it restores back to the original stage. Okay, so it monitors the regular time intervals at what time that particular crashes occurs. So this particular thing will be monitored by using this reset. Then third will be the oscillator circuit. Oscillator circuit is nothing but commonly in microcontrollers there is about 13 to 16 megahertz type of crystal oscillator have been used. So that oscillator circuit will be used for mainly that oscillator is used to generate the clock pulses. Okay, for mainly used for generating the clock pulses. Okay, so next will be the input devices. Input devices is nothing but, so there are more number of input devices like keyboard, mouse, joystick, right? So these are considered as an input devices. Okay, and similarly, interfacing or driver circuits. Interfacing or driver circuits in the sense, suppose we are going to operate any one hardware, we need the software that should be embedded into that particular system. Then only we are able to operate that particular hardware device. So these are called as driver circuits. Clear? So driver circuits mainly the driver software should be needed to particularly operate the particular hardware. Okay, that is one of the module. Then processor. So nowadays we are using a different type of processors like Pentium 3, Intel processors, AMD processors, right? So these type of processors that has been used. The next will be the timers. So timers, if you just consider 8051 or 8085 microprocessors or microcontrollers, okay, so there involves a separate type of timing, and the timing devices will be there. Timer 0, timer 1. So like the timing devices, it also monitors the regular period intervals of time. Then interrupt controller. So this module mainly used, that mainly will be operated on based on high priority. So interrupt controller, suppose if the program that has been executed, suddenly one interrupt occurs. So that interrupt will be based on the priority. So based on the priority, the particular interrupt will be serviced. So that is called as interrupt controller. So program memory and data memory. Program memory and data memory in the sense, we have both type of volatile memories and non-volatile memories, which is considered as random access memories or read-only memories. So random access memories in the sense, these considered as a volatile memory, and read-only memories are called as non-volatile memories. So that will be present under program memory and data memory. Then another module will be the serial communication ports. So there are two types of ports already. We know that serial communication and parallel communication. So under serial communication port, we use RS-232, RS-485, controller area network. So these are some type of serial communications. So the port that is being interfaced with a particular module. Then parallel ports. So parallel ports again, it is used to interface the hardware module. Then application specific system circuit. So under application specific system circuit, this is a special type of circuit that does not involve in all type of embedded system. So that is considered as an application specific integrated circuits, right? So this will be present in some of the type of embedded system. The last one will be the output interfacing. So under output interfacing, mainly we are going to monitor on screens. So mainly we are going to monitor on screen, the display devices. So these considered as an output devices. So these are the some of the components, the general components that present under embedded system hardware. We are going to discuss each and every module briefly. Embedded processor. So embedded processor is a part of embedded system. It has two essential units. One will be control unit, next will be the execution unit. Control unit fetches instructions from memory, and execution unit includes ALU and circuits. So mainly this control unit controls all the operations that takes place under address bus, data bus and control bus. So This execution unit mainly executes in ALU already you may know that arithmetic logic unit, which performs all the type of addition, subtraction, multiplications, and the division. All type of arithmetic operations have been carried out. So that is one of the module. So next will be the power supply, reset, and oscillator circuit. So this is a very important component under the embedded system. Most of the systems have their own power supply. Some embedded systems do not have their own power supply. These embedded systems are powered by external power supply. Note that in all the type of embedded system, there is not a predefined type of power supply has been provided. In some type of embedded system, some external devices needs to be powered to turn on the particular device. So these embedded systems are powered, for example, USB based embedded system, network interface card, graphic accelerator are powered by DC power supply. So commonly, for example, USB universal serial bus, you people already noticed that there are different versions under USB, USB type A, type B, type C. So based on these types, your data transfer may get varied. Okay, so that does not have a inbuilt power supply. So the USB has a, you have to provide the external supply, you have to provide the separate supply to the common pen drives. So pen drives are considered as a USB. And next one will be the network interface card. So this is called as NIC card, NIC card. So that it is a similar to sound card, graphics card, network interface card. So whatever else that is a separate type of card that need a separate type of power supply. That does not have an inbuilt power supply. And graphic accelerator. Graphic accelerator in the sense you may notice in some of the CPU, some graphics card has been utilized. So that also need a separate type of power supply. There is no inbuilt supply has been given to these cards. Reset. So reset means the processor begins the processing of instructions from the starting address set by default in a program counter on power. So commonly this program counter, there is a meaning is there, right? Program counter. The counter is nothing but it counts by one value. The program counter only all the instructions have been fetched. So by implementing this program counter, the instructions will be how the instructions will be executed. Okay. So mainly this at the time any interrupt or anything occurs, this reset is nothing but the watchdog timer circuit. So this type of timing circuits will be able to monitor the time at what time this particular system crashes. So this time and date and all the sequence have been monitored. So next will be the clock circuit controls the execution time of instructions. CPU machine cycles. So this is the another module, power supply, oscillator, and the reset circuit. So next module will be the timers. Timer circuit is suitably configured as a system clock. So for this I can give a best example. Suppose in a PC, so in this common PC, you just see the task bar. The time will be running, right? So that is based on some RPC, real-time clock module. That has a separate module. So based on that module, the clock will be synchronized. So that is an RPC, real-time clock that comes under timer circuit. To schedule the various tasks and for real-time programming, this real-time clock has been introduced. So there it was a timer circuit. Next will be the program and the data memory. So you people already noticed that what is called a program memory and what is called as a data memory. So you may be aware of volatile memories and non-volatile memories. volatile memories is nothing but, suppose if you turn on the power supply, volatile, it can able to store the memory. Non-volatile memories are, if your power supply is not there, the complete operation, the complete memory will be erased. So here in embedded system, the secondary memory like this is avoided. Most of the embedded processors have internal memory such as read-only memory, random access memory, flash memories, electrical erasable programmable read-only memory, electrical programmable read-only memory, and programmable read-only memory. So here the meaning is the read-only memory in the sense it can able to read the data, it can able to write the data. So these are considered as program memories and data memories. It's one of the modules that has been present under embedded system. And the last one is interrupt controller. So you will already notice that interrupt is nothing but based on the priority this ISR will be service. Interrupt service routine ISR. So this it is an interrupt handling mechanism which must exist in the embedded system to handle interrupts from various processes and for handling multiple interrupts simultaneously pending for service. Suppose the microcontroller, suppose for an example we consider our common PC. So in PC we have an Intel processor or AMD processor. Suppose our processor has been carried out, suddenly if you got any mail or some pop-up will be occurred. What happened? That processor suddenly execute based on the priority. Suppose you are getting a mail, you will get a pop-up, right? So after that, what happened? Your processor execute that particular interrupt and again it back to the original stage. Okay. So whatever the interrupt is, interrupt handling mainly based on the priorities. So according to the priority, this interrupt will be get serviced. IO ports. So what are the input and output ports? No need to go deeply into that, but you already know that what are the input port, keyboard, mouse, joystick. What are the output ports? Monitor. So which able to display devices are considered as an output devices, right? So here, under the IO ports are used to interface external devices like sensor, key buttons, transducers, LED, LCD, alarm, value, printer, etc. So there are two types of ports. One is parallel port and the serial port. So the parallel port are used in short distance communication, while serial port are used for long distance type of communications. So that comes under IO port. The next module will be input and output device interfacing. So whatever the input and output devices we are interfacing, we need a separate type of driver software to work that particular hardware. Okay, so here some IO devices like motors, actuators, value, sensors are not compatible with the processor. Hence, IO interface circuits are designed to drive such input and output devices interface to the embedded processor. So whatever the thing you are going to embed, that need a separate type of software to run effectively. So these are called as driver softwares that comes under input and output device interfacing driving circuits. The last one is application specific system circuits. In commonly just considered in some type of applications, this ASIC type of circuits will be there. Not in all type of embedded systems. So that only it is named as application specific circuits. In some type of applications only this ASIC type of circuits will be present. Suppose these are the circuits that can control a specific target circuit. So they consist of ADC, BAC, relays and sensor. So what are the devices we are using this type of circuit? Analog digital converter and digital to analog conversions and relays and the sensor. So in this type of modules we use this ASIC type of circuits, that is called as application specific system, integrated